log odds, log of odds, so I can represent it like this, is equal to, let us just say I'm going to create some coefficients here, 16.1259 plus, let us just say 0.5878 times x. This is your log odds representation of a logistic regression model with one variable x. So I think let me just zoom it a bit because you can see it clearly and it is recorded well for easy viewing. So I'm going to separate these coefficients into different columns so that I can show some computation using examples. So I'm going to say minus 16.1259 in this cell, and in the adjacent cell I'm going to say 0.5878, and in the last cell let us say I'm going to call it x, and we are going to substitute a value for x. Let us just say for example I can take x to be, let us just say 28. So what I've done, I've taken from this right hand side of equal to, separated the values into three different columns. So what we can calculate is for a value of x being 28, we go ahead and create the log odds. So what will be log odds now? I'm going to say log odds is equal to, we can think of it as equal to, I will say this value of minus 16.1259 plus we have the value of 0.5878 multiplied by 28. So this is what you will get, 0.3353. Let us keep it at four decimal places. Here is the first question that I'm asking you. Should this be log odds linearly related to the independent variable x in a logistic regression setting? What do you think? If in case, let us just say if in case the log odds, that is log of p by 1 minus p, is not linearly related to independent variable x, let us say in a logistic regression setting, what do you think would be the consequences? So let's continue. We have calculated the log of odds. So from this log odds, you have to go to calculating the probability. So before that, I need to get rid of this log. How do? I want to get only the odds on the left hand side. For getting the odds on the left hand side, how will I do? I have to exponentiate the right hand side and the left hand side, because logarithm and exponentiation are opposite of one another. So I'm going to exponentiate, so logarithm gets cancelled out. So I shall remain with only the odds on the left hand, and on the right hand side I'm going to say equal to sign for invoking the Excel function, and I'm going to make use of this value 0.3353 and then exponentiate them on the right hand side. So what you get would be a value 1.39835983 for the odds. From the odds, I have to calculate the probability. Probability is equal to, I'll just write it here, is equal to odds upon 1 plus odds. I can calculate the probability now. So I'll put it here. I'm going to say probability, that is equal to, this is odds divided by 1 plus, again the same cell I select, voila, I get the probability to be 0.58. So we have started with x is equal to 28, converted that into odds using the idea of exponentiation, and therefore calculated the probability using the idea of odds. So when a value of x is equal to 28 is substituted, you are going to get a value for probability that is 0.58. Remember, always probability should be between 0 and 1, cannot be negative and cannot be greater than 1 while being positive. Notice something here, we have probability to be 0.58, let us just highlight this and keep it, and I want to draw our attention to the odds. For the probability of 0.58, odds is 1.3. You notice here odds is greater than 1. So therefore, while probability has to be in an interval of 0 to 1, odds can be greater than 1. If you go on varying the value of x, you'll get a sense of what the odds are for that value of x given this mathematical representation, and therefore you can calculate the or compute the probabilities. Always remember, it cannot exceed 1. If it exceeds 1, you're doing something wrong, or if it is negative, you're doing something wrong. So here are three important questions that I want to ask. 3 or 4? 1. Should the log odds be linearly related to the independent variable x in a logistic regression? Second, can the odds be negative? Think about it. That is the second question. Third question, you observe this probability, it will approach 1 or it will approach 0 depending on different values of x. Here are two questions related to probability. For exactly what value of the probability, you will get odds is equal to 1. See here, for the value of 33, we have the probability 0.96 and odds is 26.43. For what value of probability, odds would be 1. Okay, that's the third question. Fourth question, for what value of probability, odds is undefined? I want you to think about these 4 questions and drop your inputs in the comment sections down below. I think it will be interesting for you to be able to apply yourselves and then come up with answers. Okay, don't hesitate to share your thoughts, share your inputs, share your answers, ask any questions related to what I covered.